Okay, welcome back to another video on the Maths channel. It's your teacher, Miss Lim here. In this video, we're going to be looking at relative frequency. So I've got the relevant syllabus dot points here. If you want to read them, just pause the video and read through that. Okay, so let's have a look at the first part of this lesson, which is looking at the difference between theoretical probability and relative frequency. So we're going to complete the table below to illustrate the sample space of all the possible outcomes of flipping a coin and then rolling a die. So I'm going to flip first and then roll second. So we could get heads and then 1, heads 2, heads 3, heads 4, heads 5, heads 6, or tails 1, 2, 3, 4, 5, and 6. Okay, so we could get any of these. Find the probability of heads 3. Well, we can see here that there's only one head 3 out of the 12 outcomes. So this is equal to 1 out of 12. Okay. Tails 5, only 1 out of 12. T2, only 1 out of 12. So theoretically, each outcome, you can see, has a 1 in 12 chance of occurring. But what if we conduct this experiment 12 times? What if we were to, flip a coin and roll a die? What would actually happen? So I've got a little experiment for us. So here we go. We are going to flip a coin and roll a die 12 times. And I'm going to record how many times each of these outcomes actually does occur. So I'm just going to scroll up here. All right, so let's flip a coin and roll a die. So that's heads 2. So I'm just going to do a tally. Okay, heads 2. Tails 6. Tails 4. Head 6. Tail 6. Tail 3. Heads 1. Tails 5. So 1, 2, 3, 4, 5, 6, 7, 8, 4 more times. Heads 5. Tails 6. Head 6. And tails 4. Let's just double check that we've got 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So according to the results of the experiment, I just picked 3 random ones. The probability of getting heads 3 is actually 0. Tails 5 is 1 out of 12. Tails 2, also 0. But what if we were to look at some of the other ones, right? Let's have a look at tail 6. Okay, the probability, so we'll call this question D. The probability of tail 6 in this experiment is actually 3 out of 12, which is equal to 1/4. 1/4 of the times that we rolled a die and flipped a coin, we got tails in 6. So even though the theoretical probability of each outcome from flipping a coin and then rolling a die is 1 out of 12, the relative frequency is not always 12. So what is the difference? Okay, so let's have a look at some definitions. The theoretical probability is what the probability should be. Okay? What the probability should be in theory. So for example, probability of heads, it should be half. The probability of rolling a 3 should be 1 out of 6. The probability of flipping heads and getting a 3 should be 1 out of 12. But relative frequency, also known as experimental probability, which is what we looked at in year 7, is actually what the probability is based on the results of an experiment. Okay, so it's not what it should be, it's I've conducted an experiment. What are the results of the experiment? What's the probability based on those results? Okay, so that's what we have here, right? These are the experimental probabilities or the relative frequency. So the relative frequency of heads 1 is 1 out of 12. Of heads 2 is 1 out of 12. Of heads 3 and 4 and tails 1 and tails 2 is 0 out of 12. Of heads 6 and tails 4 is actually 2 out of 12, it's 1/6. And of tails 6 is actually 3 out of 12, or 1/4. Okay, so they're not all 1 out of 12. Now, to find the relative frequency, this is the formula. Relative frequency is just the number of times the outcome occurs divided by the total number of trials in an experiment. So in the experiment we just conducted, there were 12 trials. How many times did it occur? Well, tail 6 occurred 3 times. Okay, so it's 3 out of 12. Now, what's important for you to know is actually the more trials there are in an experiment, the closer the relative frequency will be to the theoretical probability. Alright, so I know I conducted that experiment 12 times. But if I were to scroll back up, what would happen if I actually conducted this experiment 100 times, 1,000 times, 1,000,000 times? The more trials there are in an experiment, the more these probabilities, right, the probabilities of every single outcome will be closer to what it should be, in theory, 1/12 each. Okay, some of them are 0 at the moment, some of them is 1/12, some of them is 2/12, some of them is 3/12. But the more we conduct the experiment, the closer these probabilities for the relative frequency will be to what it should be, 1/12. Alright, so let's have a look at some questions. Find the relative frequency of these events. An experiment of tossing 2 coins was completed, and the number of heads recorded in the frequency is recorded in the frequency table shown. So, we flip 2 coins. How many times do we get 0 heads? We got it 100 times. How many times do we get 1 head, 1 tail? We got it 192 times. How many times do we get 2 heads? 108 times. Okay, so in order to work out the relative frequency, we need to take the frequency divided by the total number of trials. So what we can see here, right, so this is our formula. What we can see here is we don't have the total number of trials. We don't know how many times did we toss these 2 coins. We need to work that out first. So we can see here that the total, in fact, the total number of times the 2 coins were tossed is just the sum of each of these. So I'm going to add them together. 100 plus 192 plus 108 gives us 400. So that means we tossed the 2 coins 400 times. So the relative frequency of getting 0 heads is 100 out of 400. Or 1/4. Of getting 1 head is 192 out of 400. Now let's see if we can simplify that. 12 over 25. What about 2 heads? 2 heads will be 108 out of 400. Let's simplify that. 27 over 100. Okay, so this is the relative frequency of flipping heads based on the experiment, which we tossed 2 coins 400 times. Right? So we should be expecting, in theory, 100 0 heads, 100 2 heads, and 200 1 heads. That's what it should be in reality. But according to this experiment, it's not. Now, from a previous video, from a previous lesson, you should know that all of these probabilities should add to 1. Right? So if we were to do 1 corner, plus 12 on 25, plus 27 on 100, it equals to 1. Alright. The frequency table shows the outcomes of an experiment. What is the relative frequency for the following outcomes? Why don't you pause the video and have a go with this one? Okay, so we need the total. So I'm going to add all of these together. We've got 12, 9, 15, and 6. 42. So we can see here that the relative frequency of the letter A is 12 out of 42. B is 9 out of 42. C is 15 out of 42. And D is 6 out of 42. So we can just simplify all of these. 12 out of 42. 2 on 7. 9 on 42. 3 on 14. 15 on 42, 5 on 14, and D, 6 out of 42, which is 1/7. And again, all of these should add to 1. Okay, because if we think about it, they will all add to 42 over 42. Alright, we've got 2 more questions. These are both HSC questions, so we got the 2018 General Maths question 26A and the 2015 General Maths 26E. Why don't you pause the video and have a go with these 2. Alright, Jeremy rolled a biased 6-sided die a number of times. He recorded the results in the table. What is the relative frequency of rolling a 3? So it's important for you to remember, relative frequency is a probability. Okay, we need a fraction, we need a decimal, a percentage, somewhere between 0 and 1 or 0% and 100%. Okay, usually it's always easiest to write as a fraction. So, rolling a 3. Rolled a 3 48 times. Out of how many times was the experiment conducted? Well, that's where we add all of these numbers. Okay, so let's add all those numbers together. 23, 19, 48, and 20, 21, and 19, 150 times. So the relative frequency of rolling a 3, which is a probability, is 48 out of 150. What does this simplify to? 8 on 25. Alright, in 26E, the table shows the relative frequency of selecting each of the different colored jelly beans from packets containing green, yellow, black, red, and white jelly beans. What is the relative frequency of selecting a red one? So here we don't have the red, but what we do know is that when we add all of the probabilities together, all 5 of these, they will add to 1. Okay, so let's look at this one here. The probability of green plus the probability of yellow, black, red, and white. They're all equal to 1. So we've got 0.32, 0.13, 0.14, 0.24. It's going to equal to 1. So therefore, the probability of red is equal to 1 minus all of these other ones. So 1 minus 0.32, 0.13, 0.14, and 0.24. 0.17. That's the probability of getting a red jelly bean. So part 2. Based on a table of relative frequencies, what is the probability of not selecting a black jelly bean? So this is from our previous lesson where we looked at complementary events. We know that the probability of black is 0.14. So the probability of not black is equal to 1 minus the probability of black, or 1 minus 0.14, which is 0.86. Okay, or 86%. Or, as a fraction, 43 on 50. Okay, you could have just added all the other ones. You could have added 0.32, 0.13, 0.17, and 0.24, but it's easier to just think about it as the complement. So 1 minus the probability of black. Alright, so that's it for this lesson. So what did we look at? Okay, today we looked at relative frequency. We looked at the difference between theoretical probability and relative frequency, where theoretical is what it should be in theory, but relative frequency is what's the probability based on the results of an experiment already conducted. Okay, so we conduct an experiment, these are the results, what is the probability? That's what relative frequency is. Alright, so that's it for this lesson. If you have any questions, just comment down below. If you found it helpful, if you liked it, please give it a like. And if you would like more content, please just subscribe to my channel. And I'll see you in the next video. See you.